All right, so this is Mars Flight VR, simulating the Ingenuity helicopter on Mars, and how can game technology help in aeronautics and astronautics. That's my email address. That's my Twitter if you want to follow me for updates. Thanks to Ken for inviting me. It's a pleasure to be here. I'm going to talk about what is Mars Flight VR and show you what the game looks like. Talk about how it's made and why I made it. And then I'm going to show you some of the stuff I'm working on, the research projects I'm working on, which involve using game engines as simulation tools to solve prototyping issues. So yes, as Ken said, I'm actually from Ireland and I now live in Australia. I direct a company called IO where we make game simulations, VR, and augmented reality apps. I work as a researcher at RMIT, and I teach games, game development, game design, and 3D graphics. So what is Mars Flight VR? Well, the easiest way for me to explain it is to show you a video so you can see what it looks like. So hopefully this will play okay. If you have trouble seeing it, like I said, I'll put a recording on YouTube, but I'm hoping this will stream at a reasonable frame rate. You can see what's happening. So this is a recreation of Jezero Crater, where Ingenuity is about to fly. It's been delayed, so it hasn't actually flown yet. You take control of the helicopter using an Xbox controller. So you fly it with a gamepad like this, and you wear a VR headset so that you can freely look around and see the landscape. I've recreated the landing site and 35 square kilometers of the surrounding area. I've added gameplay to make the game entertaining to the general public. So the purpose is not solely simulation, but to do some science advocacy and outreach to get the general public interested in perseverance and ingenuity. So you have little quests where you take photographs. There are races where you can race around on Mars. There's a first-person view like this where you can fly inside the helicopter view. This is very popular on Earth for people who fly FPV drones or first-person view drones. They like to race drones with a camera mounted on them. And so this simulates that sort of point of view. And as I said, the game covers a lot more terrain than Ingenuity will actually ever see. This view from the top of this hill gives you a nice overview of the whole landscape. So here we see the whole river delta. Perseverance has actually landed way down in the bottom left here and is going to drive over behind that outcrop, which is one of the outcrops of the river delta. But in the game, you can explore much further. So that's what it is. Let's talk about some of the key features. So the landscape is based on the HiRISE digital terrain model. So the HiRISE camera is an instrument aboard Mars Reconnaissance Orbiter, and it's flying over Mars, taking photographs, but it also generates digital terrain models, 3D height maps of the terrain. And this is one of them here on the right. The X is the landing spot for Perseverance. Can you put him as the only person? Yeah, if whoever's in charge of the presentation could mark me as the only speaker, that would be great. Thanks for that comment. The white box there shows the area that's playable in the game. This X is the landing spot, and the rover will actually just travel west from here, so the game allows you to see a lot more. It simulates the correct Martian gravity and atmospheric density, so the helicopter falls at the right rate. There's extremely low drag. Unlike flying on Earth, it's difficult to change directions if you reach a high speed because the drag is so low. And it's in VR, and everything's better in VR. It supports all the PC-based VR headsets, and it's available on Steam. So that's the Valve Index, the HTC Vive, the Windows mixed reality headsets, and the Oculus Rift. Okay, how is it made? So the short answer is it's made with the Unity game engine. There are two main game engines that everybody uses to make games these days, the Unreal Engine and the Unity engine. And in this case, this one is made with Unity. But it didn't just come out of nowhere. So I want to talk about how I developed the skills to make this game and what led to it. So I actually made a science fiction game in 2018 called Caves of Europa, which already had helicopter style physics, but in 2D. So I'll show you a clip of this. So as you can see, Caves of Europa was a flying game, but it's locked to 2 dimensions. The camera is locked to a side view. It's a science fiction story where a comet hits Europa and cracks open the ice, and so a rover is sent to explore under the surface to look for life under the ice in Europa. And this hypothetical flying rover is exploring, and you take direct control of it with the gamepad. So I made this in 2018, and towards the end of the project, I started thinking about full helicopter physics. As I had done a two-dimensional physics-based game, I started to think, well, maybe I could take this and develop it into a full helicopter simulator. And so I made this prototype of a VR helicopter simulator to explore some ideas. So you can't see it in the video, obviously, but when you're in VR, the heads-up display is projected on a sphere around you, and you can perceive the depth of it. And it's projected 5 meters in front of you so that your eyes are very relaxed, that you don't have to pull focus to change from looking at the landscape to the heads-up display. And the little dot, you might see the little green dot in the center of the view there. That's your velocity, and it moves forward and backwards in the z-axis to show you how fast you're going. So traditional heads-up displays really only work as a flat surface. But in VR, your HUD can incorporate depth. And so I used the depth of the VR to show you how fast you're going. It's a very intuitive way to show the viewer. And I'm very interested in incorporating user interfaces into VR. I think it's a fascinating area of research. So I had a helicopter simulator, and as you can see from the sky, I was already thinking about putting this on Mars, but I didn't have a specific location in mind. This was just a randomly generated scene. However, in parallel to this, I'm very interested in 3D printing, and I have been 3D printing landscapes and then painting them to look realistic. On the right here is a crater lake in Oregon, and on the left is Valles Marineris on Mars. And these are taken from NASA's public domain height data, which are available to everyone. But I was also printing the high-rise digital terrain models. So these are available for free at this website. University of Arizona maintains the high-rise instrument. And they're beautiful. They're, let me just get my large view. So this one, for example, this is the landing site of Curiosity rover. This is looking at Mount Sharp. Here you can see a riverbed, and Curiosity is driving up towards this right now. It may eventually climb up onto this riverbed soon. So I really enjoy printing these slices of Mars. They make it seem more real, more tangible. They're very good to show to students, to show to other people the topology of Mars. These aren't realistic colors, by the way. These are exaggerated or stretched false colors in the style of the high-rise press release images. Mars isn't really this blue. So I thought, I wonder, could I get a high-rise digital terrain model of the landing site? So when NASA announced that they were going to land at Jezero Crater, had a look on the high-rise website, and I found they had a very nice digital terrain model of Jezero Crater. And so I thought, well, why not put this in my sim? This seemed like I had a thank you, KH. This seemed like I had many skills all coming together and allowing me to make this thing, a knowledge of the high-rise digital terrains, experience in VR, and experience making a helicopter sim. And it seemed like, well, obviously I should make a sim for Ingenuity. However, it's not that easy. It's not that easy. First of all, making the color of the landscape is difficult because the high-rise images are not photographed in RGB color. It has an infrared red and blue filter on the color camera, but also it only takes a very narrow strip of color photo. The instrument is on the Mars Reconnaissance Orbiter orbiting Mars. If any of you remember those old scanners, those old document scanners which had wheels on them, and you would drag the scanner along a document to scan the text. High-rise data is a little bit like that. It flies over Mars, looking down, scanning a long, thin strip. And the central color region is very narrow. It's about 1 kilometer wide. So I needed a lot more color. So I couldn't really use the high-rise textures as color. Handheld scanners, that's right. The older members of the audience will remember handheld scanners from before you could photograph everything on your phone. So I needed to texture 35 square kilometers of landscape realistically, and I didn't have a good photograph to use. So I used procedural mapping techniques. I used a plugin for Unity called Map Magic, which looks at the height map, looks at the concavity and the slope and things like that in the height map, and then automatically paints the texture. So I assembled a collection of textures by photographing rocks on Earth and color correcting them to Mars-like colors. And then I use just some formula, and it uses this node-based network for generating the masks to create the colors. So for example, at a certain slope angle, it paints it with this dark rock. At other slope angles, it detects lighter, and these ripples that you see here are present in the height map. So these are actual sand dunes, which are obviously dynamic. They're probably not in the same place now. And the procedural texturing has picked up the variation in the height and textured them as sand dunes for me. Similarly, the level was too big to place all the rocks manually. So the resolution of the high-rise scan is about 30 centimeters. So features smaller than half a meter are really not visible. They're blurred or they're just not visible. So I had to invent all the small scale rocks. And again, I used procedural scattering techniques to do this. Doing this by hand would be too time consuming. And so what it does is it randomly places rocks on the terrain, but then it does some calculations. So for example, if there's a rock perching on the edge of a cliff, it will simulate it rolling down the hill to the base of the cliff, and then more rocks will gather at the bottom. Wherever there's a large rock, it will simulate erosion and scatter some small rocks around it. So it tries to make a reasonably realistic random rock distribution. I'm looking forward to seeing when the rover gets over here closer to the river delta, what the actual rocks are like. I'm sure they're not the same as mine, but I hope they're similar. Unity has what's called an asset store, where you can buy assets that other people have made to make your game development faster and cheaper. And so I used Map Magic to make this. I used Shader Forge and I used Microsplat. So these little tools saved me months and months of work, and they're not very expensive. They cost under $100 typically, and they save you months of work. So using a game engine like Unreal or Unity allows you to get something done, even as a solo developer. So this project is made entirely by myself in my spare time, and I wouldn't have been able to do it without these tools. Next, why did I make Mars Flight VR? One, personal enjoyment. I wanted to fly around the landing site and explore it in VR before the helicopter got there. No one else had made a helicopter sim. I should mention that my friend Alan Chan had made a very interesting game called Red Rover, where you can drive a rover around on Mars. And it includes VR too. And I contacted Alan and we've become friends because we've discussed the techniques for building Martian landscapes. Alan's game has many more different scenes in it, and it allows you to drive a rover, and it has some well, hypothetical Mars bases, what a Mars base might look like. You can explore those too. But I specifically was interested in helicopters, so I wanted to fly a helicopter around, and so I really made this game for myself because nobody else was going to make it. Second is science outreach and public engagement. It baffles me constantly why everybody else is not interested in spaceflight. Spaceflight, exploring Mars, exploring the moon, sending probes to Europa and Titan are the most interesting things I can think of that we should do with our time. And it's strange to me that not everybody else feels the same way. And so I want everyone else to feel the same way. And so making a game like this is a very good way to reach people who weren't interested in the first place. If you make a book or a documentary about Mars, the only people who it's going to reach are people who are already interested in Mars. They're going to buy that or watch that, right? But if you make a video game about something, then you have a much broader audience. The general gaming audience will be interested to try it. And so my hope is that it will reach children. Children really get immersed in VR, and I want them to get excited by Thank you. I'm glad you agree, Oliver. I want children specifically to get excited by visiting Mars and to think of Mars as a real place, not just some alien distant planet that we'll never go, but a real place. And VR is important for that. VR induces a sense of scale and awe that you don't get from a photograph. So when you see a video or even a picture of Mars, it's very easy to go, yes, that's lovely, and then just keep scrolling and not think about going there. But when you see it in VR, you see how far those hills are and how tall they are. And you look up and you see that Mars has clouds. And you look at the sun and you say, oh, the sun is smaller than it should be. That's strange, and it's dimmer. And when you look down, you realize you're up 30 meters in the air and you can see the sand blowing around. It's completely different to a photograph or a video. When you see Mars in VR, it feels like a real place that we could go. And you can imagine astronauts walking around there and exploring it. And it's particularly effective for children. Children have the capacity to completely forget about the real world when they're in VR, which is terrifyingly dangerous if you're a parent, because if you put a VR headset on your kids, they forget about their body and they'll run into a wall and hurt themselves. But my game is played seated. So my game is what's called a seated VR experience, where you sit down, you hold a controller, and you don't run around. So it's a lot safer for kids to play. And I found that VR is extremely effective on children. They lose their sense of self and they become completely in the game. And so that's a very effective way of getting young people interested in space flight, space travel, and Mars. My hope is that after COVID is no longer a problem, that I'll be able to put Mars Flight VR in science galleries and museums so that people who don't have a VR headset at home will be able to fly around Mars and see what Ingenuity saw and take photographs and be amazed by the fact that there's a river delta on Mars and a 4 billion-year-old lake bed. Most people don't even consider the idea that there were lakes on Mars, never mind river deltas. But to see it and fly around it will change their mind and make them realize this is somewhere we can go. And then lastly, of course, profit. That's a joke. There is no profit in VR video games. VR is a very, very small market at the moment. So in terms of the whole video games market, VR is less than 1%. So less than 1% of people who have a gaming PC have got a VR headset installed. So there's not much money in this. I basically made this in my spare time and funded it myself. Although I was helped, and I'm very grateful to the assistance of Film Victoria. So Film Victoria is a government body in the state of Victoria where I live, who fund film, television, and video games. And when I told them I was making this Mars experience, they got right behind it and they gave me a sizable grant, which allowed me to fly to LA and show the game at the Mars Society convention in 2018. And they provided funding for me to promote the game and to make the trailers and things like that. So I'm very grateful to them. Yeah, I'm reading the comments and there's a suggestion that it would be good to get universities to try this. I agree. And so I'm giving the game away for free. So while I have released it on Steam for the general public to buy, if any of you are interested in trying the game or showing it at universities or showing it at a museum, please just contact me and you can get it for free here. So if you type in this web address into your browser, you can fill in the form and download the game for free. And I'm happy to give as many keys as you require for your school or university or museum or anyone who wants to use it for free. I'm going to move on. I have a little more. I'm going to move on to talk about game engines in general for simulation and how they can be applied to aerospace, aeronautics, and astronautics, and to talk about some of the research I'm doing at RMIT. So this is just a smaller second part of my presentation, which I hope will be useful to any of you in the audience that are interested in robotics, simulation, remote missions, rocketry, anything like that. So I work as a researcher at RMIT, and I'm working on a project called DimSim in collaboration with Rheinmetall, and it stands for Deep Intelligence Machine Simulator. This DimSim project is made in the Unreal Engine, and it uses Microsoft AirSim. AirSim is a free expansion, an open source expansion, which works in Unreal and Unity, and it provides you the tools to simulate drones and vehicles. very easily. It's specifically designed for training autonomous vehicles and research in autonomous vehicles. And so we are trying to develop, Rheinmetall are trying to develop an autonomous off-road vehicle. Let me show you what I mean by off-road. So this is the Australian Automotive Research Centre, and this is their four-wheel drive test track. And so we want to develop an AI that can navigate a tracked or a multi-wheeled vehicle through landscapes like this, and can take instruction from human operators with hand gestures, can follow humans, and can navigate safely through mud and water and trees and things like this. So this is a much harder challenge than autonomous vehicles on a road. You've got no traffic lights, no street signs, no white lines to follow. And part of the challenge is getting the AI agents to recognize high-risk terrain, in particular mud. You can see here there's a mud pit in this landscape, and there's a water trap here. So our AI agents need to be able to recognize high-risk terrain. And so we use DimSim to train them to, DimSim to train them to do that. I should stress that this project is a major collaboration between RMIT, Rheinmetall, Queensland University, and CSIRO, and there are many other people working on this. Let me show you that where we're at the moment in DimSim. So I'm going to skip to later in this video to show you why we're doing this. We want to train an artificial intelligence to recognize different terrain types. And in order to do that, we show it loads and loads of video of landscapes, and we ask it to guess, what do you think is the tree? What do you think is the grass? What do you think is the mud? And when it provides the answers, we then verify those answers to tell it if it was right or wrong. So this is called reinforcement learning. It improves by reinforcing. So in order to do that, you've got to record real video of off-road landscapes like this, but then you have to annotate the video to mark which area is mud. And so this is, a person has gone through and marked that this is the sky, this is the trees, this is sand, and this is mud. So that when the AI guesses, I think this is grass, we can say, no, you're wrong, that's actually mud. And that reinforces the algorithm, and the next time it runs, it gets better. And this is very time consuming. Obviously, it takes a long time to film this footage. It takes a long time for a person to annotate it, and then we run the reinforcement learning agent to get better. We want to use DimSim to generate realistic video footage that's already annotated. And so DimSim can do that. So DimSim can generate, on the left you see the realistic view of the forest, and on the right you see the annotated version where it's marked, this is sky, this is trees, this is grass, and this is sand. And so we can now generate unlimited footage which has realistic view and annotated view in order to train the AI agents, which saves a lot of time and a lot of money. I'll show you the current state of the simulation. We're particularly interested in realistic mud because filming realistic mud and recognizing realistic mud is very difficult, but it's also a high priority because vehicles tend to get stuck in the mud. So we've recreated that site that I showed you in Unreal as realistically as possible with the mud and the correct trees and the correct rocks. And then we're using this to generate videos to train the AI. We use photogrammetry assets, which are real objects photographed from multiple angles and then converted into 3D meshes to make extremely realistic props. So you can see the logs on the left and the trees. These are all based on real trees which have been scanned into the game engine. And they're crunched down to a lower polygon count so that they're nice and fast. But as you can see, the lighting in Unreal Engine is absolutely beautiful. One of the reasons we chose Unreal for this project is because of its high quality lighting engine and its rendering. We can change the time of day. We can render the same scene at multiple times of day, and that's important because the shadows often trick the AI agents. The shadows are confusing for the AI. It has to know that this change in color is due to a shadow or lighting change. It's not due to a surface change. And the only way for it to learn that is by repeatedly running over multiple videos. So that's one of the projects I've been working on at RMIT. That one's called DimSim. Another project or a smaller tool that I've developed recently is a LiDAR visualization tool. Any of you that work in autonomous vehicles or remote sensing are probably familiar with LiDAR. It's laser range finding. a device shoots out a laser beam, and where the reflection is detected, you measure the time that it took, and you can detect how far away it is. And so a LiDAR lets you build up a three-dimensional image of where you are. The specific LiDAR that's being used on this project looks like this. It's the Velodyne VLP-16, and it's mounted on a rotating platform. You notice they're offset at 45 degrees and rotating. And so this tool that I've developed allows us to simulate the returns from LiDAR at different rates, different positions on the vehicle, different speeds of the vehicle, that kind of thing. So let me explain what we're seeing here. This bottom area is the forward view from the vehicle. And the top area is a top-down view of a sort of a test track where we want to see what kind of LiDAR pattern we will get. And so this tool lets me run the vehicle along a test track and record how many of the LiDAR rays miss because they're shooting up into the sky, or hit the vehicle, which means they were wasted, or hit the terrain and return a green dot. And I've marked the LiDAR returns with green dots here. So we can do things like we can move the LiDAR around. Let me show you. I'm going to skip forward a little bit. So here I'm going to change the speed to 60 kilometers an hour to see what the LiDAR return looks like when the vehicle's moving quickly. You can see in the bottom view exactly what it's seeing. So obviously driving this vehicle at 60 kilometers an hour would be quite risky because it doesn't have a very good view in front. Here I'm going to move the LiDAR to a different location to explore what kind of return would we get if we put it on top of the vehicle in a different angle. And so here's the vehicle that it's mounted on, and I'm moving it over to the top and then switching its mount angle from 45 degrees to 10 degrees. And then running the simulation again. And now because this is in a game engine, we get the results straight away. We don't have to click render and wait an hour for the returns. We can see them happening in real time. So you can see the points that the LiDAR is detecting in this point of view. So this tool allows us to test different LiDAR configurations, different types of LiDAR, different angles for mounting on it, all in software without having to do any mechanical prototyping. I'll skip forward a little bit just to show you another type of LiDAR as well. That was a Velodyne LiDAR, and this is a Baraja LiDAR, which is a newer LiDAR that uses a different scanning system. And you'll see it returns a completely different scan style. This LiDAR, instead of sweeping 360 degrees around the vehicle, focuses all of the attention in front in a very narrow, high-density point cloud. And you'll see when I run it, the different style of return. And so this one is more like a beam focused in front of the vehicle, which is very good for fast-moving, forward-moving vehicles. And of course, you can always mount it at a different location. You can pause the sim and fly forward. These obstacles out here are supposed to represent a tree or a person or something small. And so we can count how many dots are being detected on small items. That's, you know, at whatever range in the future, in the distance you're interested in, to work out if this LiDAR is effective. You can see the density from this return is almost like it's almost 100% coverage. It's very good. Okay, so in conclusion, game engines provide a cheap and fast solution for developing simulations. They allow for problem discovery and troubleshooting before the hardware manufacturing stage. So I highly recommend integrating game engine simulations into your product development pipeline, whether it's for rockets or for rovers or whatever systems you're working on. Okay, that's all I have today. Thank you all for watching. If you would like to follow what I'm working on, you can follow my Twitter. If you'd like to contact me directly, please email me. And as I said, you can get a free copy of Mars Flight VR. If you have any PC VR headset, it'll run.